of all real polynomials of degree less than equal to 3 together with the zero polynomial over R, and let W be the subspace of the vector space V, which is given to be as all those fx belonging to V such that f of 1 is equal to 0. So this is a subspace of B, and we need to find the basis of W, the dimension of W, and also extend the basis of W to a basis of V, right? Okay. So let's take fx to be any polynomial of degree less than equal to 3. So I'm taking fx to be a plus bx plus cx square plus dx cube, where that is the polynomial belonging to the subspace W. And because it is given to us that f of 1 is equal to 0 for W, right? So if I put x to be equal to 1, I get f of 1 to be equal to, yes, just put here x equal to 1, we get a plus b plus c plus d, and this is equal to 0. So from here we say that the value of a is equal to negative of sum of b plus c and d, right? So therefore, if I write f of x again, just writing this a as this, that is negative of b plus c plus d plus bx plus cx square plus dx cube, which can also be written as, let's take b common from these two terms. So this is b into x minus 1. Similarly, I am taking c common. So this is x square minus 1. And then d into x cube minus 1. So what we see is that fx is a linear combination of x minus 1, x square minus 1 and x cube minus 1, right? But fx is arbitrary. We can take any polynomial of fx of the kind a plus bx plus cx square plus dx cube from the subspace W. So fx is arbitrary. That means every polynomial of the kind f of x that belongs to W is a linear combination of these three polynomials, x minus 1, x square minus 1 and x cube minus 1, right? So thus fx is a linear combination of the polynomials, yes, x minus 1, x square minus 1 and x cube minus 1, but fx was arbitrary. So therefore every polynomial of W is a linear combination of these three polynomials. Thus W is generated by these three polynomials, and when W is generated by these three polynomials, that means these polynomials are linearly independent. Why? Because none of these polynomials is a linear combinations of the preceding ones. They are having the degrees in an increasing order. It is of degree 1, it is of degree 2, it is of degree 3, right? So none of these polynomials is a linear combinations of the preceding polynomials. So these polynomials are linearly independent. Now since none of the polynomials x minus 1, x square minus 1, x cube minus 1 is a linear combination of the preceding polynomials, so therefore these polynomials are linearly independent, which also forms the basis for W. So basis of W is x minus 1, x square minus 1 and x cube minus 1. And number of elements present in the basis is 3. So dimension of W is 3. Now since this set is a linearly independent subset of V, right? And what is the dimension of V? V is what? It is a set of all the polynomials having the degree less than equal to 3, right? And what are the standard ordered basis for V? It is 1, x, x square, x cube. These are the standard ordered basis for V, right? And number of elements is 4. So dimension of V is 4. And how many number of elements we are having here? 3. Can I add 1 also over here? Yes, 1 can be taken as x to the power 0. So this complete set is also linearly independent subset of V, right? So number of elements now becomes 4. So these forms the basis for V. So the basis of V becomes 1, x minus 1, x square minus 1, x cube minus 1. Total number of elements 4.